what is TensorFlow basically? From starting, we need to understand. Okay, so talking about the TensorFlow, basically, it is kind of framework in Python. Okay, it's a framework. That's it. What is a framework? Like we had, NumPy, Panda, all these things, right? Which is to, perform multiple actions, which had multiple classes, within classes, multiple methods in them, right? Similarly, we have a TensorFlow, a kind of framework which will be used to perform many complex calculations, complex computations, which your NumPy or Panda will not be able to do because it will work on tensors. The TensorFlow entirely work on tensors. Okay, this is the basic thing about the TensorFlow. Then what is tensor? Okay, so the TensorFlow, uh, they use a special type of data structure basically within them, which is called tensor, and those tensors are used to represent the data in graphical formats. Okay, so whatever is done in the tensor inside the TensorFlow, it will be done by the use of tensors. So all the computations, all the any calculation, any complex computations, is carried out by tensors. A special kind of data structure which is called tensor. Okay, they are also the data are also stored in the tensors. So tensor is a multi-dimensional array. You can call it as 0D array for a scalar values, 1D arrays, or vectors. Okay, so this is simply a kind of computational graph basically. Okay, so as you can see in the screen here, TensorFlow will create computational graph by using the tensors. Individual blocks, individual nodes that you can see here, those are called tensors. Okay, so what is graph then? Okay, what is graph here? So the biggest idea about TensorFlow is that all the numerical computations are expressed as a computational graph. In other words, the backbone of any TensorFlow is a graph. So here, anything that happens in your model is represented by computational graph. This makes it the to-go place for anything related to your model. Okay, so say here I have any function in x and y, say fxy here, as you can see here, fxy. Okay, which is given as x square y plus y plus 2. This is a function and that you need to calculate. How TensorFlow will create the computational graph using the tensors. Okay, it will allocate multiple tensors for multiple variables here. Okay, and multiple operations, right? So here we have x square y, right? So first it need to take values of x twice. Okay, so it will take from a node called x. It will take the values of x twice, x square. Then it will get multiplied with another node who will take the value of y. So it will take the value of y, and this y will be sent to the x square value, the cross, the multiplication thing. Okay, it will first take the x value 2 times and it will multiply, right? So it will become x square here. Now after that, it will again be multiplied with the y value, which is taken out from here. So x square y again. Okay. Now here x square y have. Then again in the next time, this y value will be added to 2. So this y value will also be added to some constant value 2. So we have y plus 2 here. We have x square y here. We have y plus 2 here. And again the two parts should be added to each other. So again the final operation will be the addition operation, x square y plus y plus 2. And this is our final function value. This is what is computational graph in TensorFlow, and it creates a lot of the bigger and bigger computational graphs within the TensorFlow. And by using that technique, this is a kind of data structure, right? The computational graph is nothing but a kind of data structure which your TensorFlow is following by using the tensors, right? And which makes it really faster for any complex computations and calculations. So the graph is composed of a series of nodes connected to each other by edges. Okay, so each node in the graph is called op, short for operation. Okay, so we'll have one node for each operation, either for operations on tensors or generating tensors like variables and constants. And each node takes 0 or more tensors as inputs and produces a tensor as an output. That's what we have here. Okay, so again, let's build some computational graph here. Okay, how will you build a computational graph? That's the question. Okay, so here I have created one variable called a equals to 2, another variable called b equals to 3, and in the third variable, what I am doing is I am taking the variables a and b, and I am adding on the tensor node tf dot add. So before I proceed, we first need to import the TensorFlow, right? How will you do that? So we just need to write import TensorFlow as TF. Okay. When we write import TensorFlow as TF, it will install the package TensorFlow as an object, as an alias, as TF. Okay. Now here we are adding the values of B and C on the node C. Okay, and we are printing C. When we run it, it will give you just add, shape, and data type. It will just give you this one. No anything. Okay, let me run here. Let me run from starting. See, it has given you a value. TF dot tensor 5 shape equals to blank, and since it's a scalar one, right? So it is giving the shape equals to this one. Then data type equals to int 32. Okay, this is what it gives you in the output. Okay, now when we see it using the tensor board, okay, it will show you something like this one: x and y and one node called add. This node add node is a part of your TensorFlow, as you can see that we have created. But this x and y are randomly taken by the TensorFlow. Why randomly taken? Why it has not assigned the name a and b? The reason being, this a and b here, we have created a Python name. We have given the Python name here a equals to 2 and b equals to 3. The Python values or Python variables we have created. We have not created TensorFlow variables, and that's why it is not allocating the same name a and b here. Okay, there is a way to name the nodes as the same node which we write here, but we have to create TensorFlow specific variables, not Python specific variables. That is a difference. Okay, so this code creates two input nodes. Okay, a equals to 2 and for b equals to 2 3, and one output node for the addition operation named add. When we print out the variable c, that means the output tensor of the addition operation, it prints out the tensor information, its name add, shape, and data type. Okay, so yeah, now what is session? So here there are two different parts here in the computational graph. One is, uh, uh, you know, uh, one is this graph, another one is session called session. Okay, what is session? So session means to compute anything, a graph must be launched in a session. So technically, session places the graph operations on hardware such as CPU or GPU and provide methods to execute them. So in our example, to run the graph and get the value of C, the following code will create a session and execute the graph by running C here. So I am running, I am creating a graph here. You can see. Okay. So this is I'm using one second. Okay. So here you need to create the session. How will you create the session? Okay, to run the any graph and compute any value from the computational graph, you need to run in the session. So this code, this two lines of code I have written extra because my TensorFlow doesn't support. This is a newest TensorFlow which doesn't support, which is not compatible with the Python version, and I need to write these two extra lines of code. Okay. So session equals to, you can direct write import TensorFlow TF, and after that you can write session equal to ses equals to TF dot session. After that print ses dot run C and ses dot close. So here what we are doing is we are opening the session here. This is a session opening code. This is nothing but we are running the value of C, which is nothing but the addition operation. C equals to TF dot add A and B, right? So similarly, we are doing some operation on this node C, which is basically some computational operation is done on the node C, and I am running the node C. I am running the addition operation within a session, and after that I am closing the session, which will give you the value of 5 finally. Okay, so this piece of code will basically create a session object, which will be assigned to sys, and then it will invoke the run method to run enough of the computational graph to compute the C value of C, the addition operation C. Okay. Any question, guys? And if you don't want to close the session, if you don't want to write this many code, if you want to skip few lines of one line of code, then you can go with this code. Both are same. With tf dot session as session print session dot run, it will automatically close the session by using this command. Okay, it will give you the same output. But again, when we have done it, again we are not able to get the values of the names of the nodes at as A and B. Okay, why? Because again we have used the Python name, not the TensorFlow name. Okay, now what we will do here, we will create three different nodes here now. Okay, what nodes we will create, we'll see. X equals to 2, y equals to 3, and add op one variable called add op, which is TensorFlow variable tf dot add this x and y, which is Python variables, and I'm giving the name of the node add op as add. Again, I am creating one multiplication operation mul underscore op, this variable, which will take the xy values and which will multiply them. Again, I am taking the power operation variable pow underscore op, which will take the add op and it will reach to the power of mul op. and I'll name the node as power. Similarly, I am creating one useless operation, which is tf dot multiply x. It will take x and it will take add op value, and it will name as useless. Name the node as useless, and it will multiply them. Similarly, power out, it will basically give the values of power out and z value. Okay, as session dot run power operation and useless operation. It will run the nodes, it will compute the values of power up and useless operation, and it will store in power out and z value. And finally, we will just use this one. We will print the values. Okay. So here we can see every node has been created. Can you see here? Add operation, useless, and power. And it will take x and y values. Okay. It will multiply it. After that, after the multiplication, it will create the power. Again, while addition, it will take x and two values and it will add them, right? After that, it will create the power. Power is nothing but add operation. Whatever the values we are getting from here to the power, this multiplication operation. Okay. And this useless operation, x multiplied by whatever the result we are getting from addition operation. So it will create the different nodes here. Okay. This is the basics of tensors, basically how we create how we create the computational graph, how we create the tensors, how we do the multiple operations in the tensor. This is a very basic one. Okay, I mean, we don't use it here to create all the basic things. We use it in neural network, but yeah, it's important to see how the computational graphs are created within the neural network. Okay. Then there are something called tensor types. Okay. So here till now we have understood what is graph and what is session, basically. The very basic things of graph and session. Okay. So now we will understand what is constant. What are the different things? Okay. What are constant? What are variables? And what are placeholders in a TensorFlow? Okay. How to create them. Okay, so constants are nothing but the same constant as we use in Python or any other languages, constant value. Okay, so whenever we will create a constant, basically they will create a node that will take values which will not change. Okay, so we can simply create any constant tensor by using the command tf.constant. Okay, so tf.constant, and under that we can pass the value. It will create a constant. So I have created one constant a, I have created another constant b, and I am adding a and b both. I am printing the result. That's it. Okay. See here, I have not given any name to this node, so it is automatically taking constant one and constant, any random name. Okay. Similarly, if you give something like this one, say a equals to tf.constant, and within which you pass the value as 2, the value of the constant as 2, and you give the name of this node as a. Similarly, you create another variable b in which you have the constant value 3, and you name the node as b. And similarly, I have another variable c which will take all those constants a and b, and which will add them, tf dot add, which will perform the addition operation. And after that, I'll name this node, wherever this addition operation is taking, I'll name this node as sum. So you can see here, I have taken all the three nodes, all the three tensors as TensorFlow specific tensors, tf.constant, tf.constant, tf.add. And here, a and b nodes are created. Okay, the nodes a and b are created with the same name as given in the code here. Similarly, the addition node by default, it will take add. The name of the node will be add, as you can see here. But when we have provided the name of the node as sum, it will take the node name as sum. Similarly, while creating a neural network, when you give the name of the node as layer 1, layer 2, you can name it anything. Hidden layer 1, hidden layer 2, anything. It will give the names. But when you don't provide the name, it will just automatically assign some random names like layer 1, layer 2, layer 3, layer 4, like this one. Okay. Or dense layer or max pool layer, anything. Okay. It will create all these things. So this is the sense constant values in the TensorFlow. Okay. Okay. You can also provide entire matrix within the constant like this one. So this is the scalar one. You can see here. You can provide the data type as well. When you provide the data type, it will take the data type as it is. You can also provide the entire matrix within a constant at any particular node. Okay. And after that, you can run both the constants, both the nodes, both the tensors. Okay. And we get the output like this. Now variable. As you can see, what is variable, right? So variables are a stateful nodes which output their current value, meaning that they can retain their value over multiple executions of the graph. And they have a number of useful features such as they can be saved to your disk during and after training. This allows users from different companies and groups to collaborate as they can save, restore, and send over their model parameters to other people. So there are a lot of uses of the variables in tensors. Okay, how to create the variable? So it's very simple again. We just have to write tf dot variable. That's it. So when we write tf dot variable, I have passed some some value as set to. Okay, and I am named this variable as scalar. So s equals to tf dot variable to name equals to scalar. Similarly, I am creating another variable, say m, where it will take two different, where it will take one matrix, entire matrix, 1, 2, and 3 for row and columns. Okay, I am creating another variable w, which is nothing but it will create all the zeros values. Okay, of 784 rows and 10 columns. It will create all the zero values. Okay, we can, if you want to see that, you can print that. If you want to do any mathematical operation, you can do the mathematical operation by running it within a session. That's up to you. Okay, now since we have this variable s equals to, this variable 2, this matrix, and this weight value. Okay, so here this variable w, as you can see here, defined above, creates a matrix of 784 rows and 10 columns, which will be initialized with zeros, as we have written here tf dot zeros. Okay, and this can be used as a weight matrix of a feed-forward neural network architecture from a layer with 784 neurons in the input layer to a layer with 10 neurons. Okay, now we will see more of that later in this tutorial, that how we can create the weight matrix and all. Okay, when we use tf dot variable with uppercase, this v, upper v, okay, and tf dot constant with lower c, you don't necessarily need to know the region, but it's simply because tf dot constant is an operation while tf dot variable is a class with multiple operations. That's why here, while creating the constants, we use tf dot c constant, which was in lowercase. But here I am using tf dot variable, So V is, in capital, because the variable is entirely a class. Okay, that's why by naming convention of the Python, we any class name shall start with a capital letter. Any method name shall start with the lower cases. Okay, these are the minor things. I mean, just to let you know that this variable is not a method; it's a class itself. Okay, it has multiple operations within it. Okay, okay. So these are the basic things. Actually, we don't use all these things. It's, just to give you an overview. What are the different components in the TensorFlow? I'm telling you about this one. Okay, nothing else. And when you create the variable, you need to initialize basically the variables. You can't run the variables without initializing. Suppose I have created three variables here. Okay, 1, 2, and 3. The same variable. Okay, and after that, what I am doing is I'm just running those variables within the session. I'm running those variables. Suppose I have created another variable, say a equals to tf dot variable, get variable, name equals to var1, and b equals to tf dot variable, name equals to var2, c equals to tf dot add a and b, right? So the problem is when we run this, the variable is not initialized. That will show you some error. That's why I have shown the error also. Failed precondition error. Attempting to use uninitialized values. Okay. So this one is like when you don't initialize the variables, how will it compute a plus b? How will it compute the values of c, tf dot add? It will not be able to compute, right? That's why it is throwing some error. So at the runtime, we need to initialize the variable. So how will you initialize the variable? So you just need to write or create one variable, say init op equals to tf dot global variables underscore initializer. Okay, this is the command to initialize the variable. That's it. When we initialize that, I'll pass it in the run, and after that we can uh, print. We can run in any session any variable created ABC, which is actually initialized first. After that, we are running all of them, and it will give you some values now. Okay. So similar to the variable, suppose I don't want to, you know, give the value at the, you know, say I don't want to give any value, for example. Okay. So placeholders, we have another component of the tensors, which is called a placeholder, which are more basic than a variable actually. So it is simply a variable that we assign data in the future time. Okay, we don't know how many input size is coming for the images, what is the value of any certain variable is coming. I don't know. So I'll create a placeholder. So placeholders are basically the nodes whose values fade in at the execution time. Okay, suppose I am creating one placeholder called A. So A equals to tf dot placeholder, and I'll say it is of shape 5, and I'll tell that it is having the data type as float 32. Okay, I'll create another placeholder B. I'll create another placeholder X. I'll create another placeholder Y. These are the commands for creating the placeholders. Now, when you run it, for example, I have created one placeholder, say I have created one constant node, say A equals to tf dot constant, we takes three values 555, and the name of the node is A. Similarly, I have created one placeholder called B, whose name of the node is B, which will take three different elements, and I am adding A and B now. Can you say here? I'm adding A and B, but I am not provided the value of the elements in the placeholder B. It says that it will take three values, but where are these three values? And without providing the values, I am running it, and it will create exception and error. Invalid argument error. You must feed a value for placeholder tensor B with data type float and shape3 error. So this kind of error you will get. Yeah, that's what I say. No, placeholder is like, okay. Placeholder, like I have created this placeholder, I have created a node, and I'm saying this, that this node will take any value of size 3 and data type float 32. And I have not mentioned anything. I'm not given any value, like I have given value here 555. Okay, I'm not giving any value. I will give this value at the execution time. Okay, so suppose I am running this code, okay, and I'll give the value at the execution time according to my wish. I'll assign some values. I am passing the same code to another person. I'm saying you can run this code, it will do some addition operation. So according to his wish, he can pass some other values. So this is called placeholder. So at the execution time, we have to pass the values. Okay, this is called placeholder. You can see here. See, I have created one constant node 555. Okay, after that I am creating one placeholder called b, which will take the shape, which will take the values of float 32 data type, and shape will be 3. Right, c will take a and b values and it will add them. And during the execution time, what I'm doing is I'm creating a variable called d, okay, in which I am saying that this d is a dictionary, okay, in which b is a key and 1, 2, 3 are the values. Okay, so this b will be assigned here in the place of b. And at the runtime, while in the session, I can run it and I can provide the feed dictionary equals to b. This is the placeholder. Next time, you can change this one. You can change the value of 1, 2, and 3. You can write anything according to your wish. And this is called placeholder. Can you see here? Here I'm not taking any value. So it is basically done in image classifications and all. For example, I am running, I am having multiple images of say 28 cross 28 and RGB C3 channels. Right. Now after that, I want to, you know, train my model on say 1,000 images. Okay. Now next time, if I fix the input shape as 1,000, okay, so it will take 1,000 images only every time. But next time, if I pass the same training module to some different person who wants to train the neural network on say 10,000 images, but your network will only take 1,000 images, that creates the problem, right? You need to change the code. Okay, to avoid that, we create the placeholder where I will give any shape, say none, which will take any shape, any size of the image. So what is the, you know, size of the images? What is the number of images basically? I'll create a placeholder, and there what it will do is it will take a number of images. If I am running, I can provide now 1,000. I am passing the same code to you. You can run the same code. You can pass 10,000 images. It will not create any problem because this is a placeholder. This is kind of variable of variables. Okay, got it? Okay, now till here, if it is fine, then we can create a neural network here. How neural network? Some basic neural network. We'll create some nodes and just assign. Okay. So first, say create a placeholder x, which will take say shape equals to none and 784. Okay, name equals to x. Now this is tricky part. Please read the above side note again. I mean, oh, wait. We need to feed b images of size 784. Can you see here? Size should be 784. And how many images? I don't know. I can create. I can put any number of images. That's fine to the network during the training size, during the training time. Okay. So the placeholder needs to be of shape b, comma 784. We have to define the placeholder of size of shape, none, and 74, which means that we can feed any number of images of size 784, not B images necessarily. It means not how many images. It's not necessary. It's up to you. You can provide. Okay. This kind of things are done by placeholders. Okay. So here you can see I'm creating one weight initializer. Okay. Then weight variable basically. Then bias variable I'm creating. After that I'm doing x into w, x transpose w, df dot multiplication x into w. Now creating a adder node, so x into w plus bias. Okay. Now create a ReLU node, tf dot nn dot ReLU on this node xwp, and whatever the output it will give, it will give the final outcome of the ReLU node. Okay. So I'm taking one x value, then weight value. Okay. Then again this will be multiplied, and this will again be added with one bias, and this entire thing x into w plus bias will be fed into the ReLU nonlinear function, and it will give some output value. That's it. This is the thing we need to do in the TensorFlow as well. Sorry, in any neural network. While creating any neural network, we need to do all these things. Okay. So here, this is the complete code. Nothing else, which will basically give you the values, the final values. Okay. This is the same thing that we have done here. We are creating the placeholder, weight initializer, then create network parameters like weight, bias, then matrix multiplication, then addition, then ReLU layer. Same thing we have done here. Okay, then after that we'll initialize the variable, otherwise we'll get error. After initializing the variable, what we'll do, we will launch all the operations within a session. That's it. Done. Okay, and here I am providing the D, the placeholder. Here the size is 784, but how many images? 100 images. So here I am providing the value of none as 100 while the runtime, during the runtime, execution time, sorry. During the execution time, I'm providing the images will be of n equal, and the number of images will be of, the number of images will be 100, and the size of each and every image will be 784. Okay, this is the thing we do. So 28 cross 20 weight, it means 784, and it will take all the 100 images of size 28 cross 28, it means 784, and it will do all the operations, like it will take 784, 100 images of size 784, and it will multiply it with the bias. It will multiply it. It will be multiplied with the weight. Then after multiplication, it will be added with the bias, and after being added with the bias, it will pass through the nonlinear function called ReLU. Okay, it will apply ReLU, and after applying ReLU, it will give you the values. Okay, this is straightforward architecture. These are very simple things in TensorFlow, with the basics of tensors basically.